Hey, what's up, everybody? This is Steve from Linux, by the way, and recently I've made some videos on Fedora Silverblue and Omarchy and Cosmic Desktop, and I normally run Steam, and we do things like run Baldur's Gate 3 or X4 or whatever, and we say, hey, gaming works on Linux. Now, that's almost a solved problem at this point because games work great on Linux, and you can run nearly any game on Linux unless there's like some odd anti-cheat. But I want to do something more interesting today, which is that we can also make games on Linux. And so there's been a great tutorial put out, which I wanted to highlight, which is by Fevin John James. So normally on this channel, DHH is my favorite person because he made Omarchy and he's pushing Linux forward, which is cool. But this week, Fevin John James made a tutorial on making games in Rust and Bevy, and there's actually multiple parts. So if you guys like this one, I'll do more of them. But this is part one, and we're going to be talking about how to make a player scroll around on screen, and we'll do it from basically scratch. So we're going to start with nothing, and then we're going to iterate and build that game up together. So if you're following along at home, you can do this on any Linux or Mac OS X or Windows because they all support Rust. In this case, I'm going to be doing it on Omarchy, and I'm using the Hyperland tiling window manager, so I'll have everything side by side. So to get started, I put the link below. We're going to open aibotH.com. No idea how to say it, but great content. And I actually don't think it's written by AI. I'm not positive, but either way, it's really easy to follow and get started with. So I'm on Omarchy, and that's based on Arch Linux, and it actually already comes with Rust and Cargo and all that. So if we do like a cargo dash dash version, I can probably make this bigger. You can see we're on 1.92.0, and that is also the current version at the time of this. If you find this later on, it won't be a big deal because these are not going to be like major breaking changes. And one of the things we want to do before we get started is you can do a pacman-ss and search for Rust Analyzer. And by default, this isn't installed, so I did install it. You should install it too, because if you're using NeoVim, it's going to be used to check our program for correctness. And so it's a really handy tool. And so the next thing we're going to do is I keep all my source code under home source. It's a pretty good pattern. And so I do src github.com sharms. That's where all my code goes. You might also want to follow this pattern just because it replicates the Golang way of doing things, basically. So Golang also has an src folder with all of the things you clone down. And I use this pattern. So like if I was to clone your repo, it would also go under my source directory, but under your domain and name, probably github.com for most of you, but you can host Git anywhere. It doesn't have to be github.com. And so from here, let's go ahead and check out the tutorial. And so I have these side by side. If you're on Omarchy, you have like a ton of options here. So you can go ahead and go like to a new workspace, and you could have them on different workspaces and just toggle between them with hotkeys. I can go back and forth between an IDE and a blank desktop. And if you're curious about the theme or whatever, Omarchy ships with awesome themes already. And you can just go to Style Theme here. And I have the E301 this week, but you can pick from any one of these, and they all look really nice. So we're going to go ahead and go back to this one, though. And we're going to go ahead and follow the tutorial. And so it shows you here, we're going to make a little sprite walking around. And there's actually a lot you can do with that right out of the box. But this is not only about game programming, it's also about learning Rust at the same time. And so through his tutorial, we're going to cover a lot of that. The basis of what we're doing today is ECS. It's an entity component system. And so everything in our world is an entity. And then we're going to configure through that. And so it's a high level abstraction. So rather than like moving an individual pixel around, we're going to operate on an entity, and we're going to see how to do that. And so we have a world system, and that's the whole world where the player moves in. In our case, it's a 2D world. Now, that's a 2D render. So you could have floors there and make it a 3D world also. So just keep that in mind. And we have an input system, and that's how we do things like make a key press, translate into movement. And so we're going to set this up, and we can make enemies and update each game loop, which is a big thing in games, right? Is so whenever you play a game, there's always a main game loop. So once you get to this certain point, it starts a loop, and then it renders a frame, and it takes input in, and it moves everything in the game world and translates it around. And that's what we're doing here. So that's a really standard thing. And no matter what language or framework you're using, they're all very similar in that respect. You can see here, there's some really nice diagrams too. So if you need visuals and all that. And so he's given us a brief introduction here to mutability. In Rust, everything is immutable by default. And to be mutable, we have to declare it explicitly. that's a huge win in terms of correctness and reducing bugs and all that. In the past, I've used languages like Clojure a lot, which is also immutable by default, and it simplifies a lot of problems. If you look at Go and like what are the common bugs, well, mutability is actually a huge problem there, and you have to wrap everything in mutexes all the time, and even then, bugs still slip through. And so this just helps with that and makes it a lot easier for the compiler to help you figure out what's going on. And so mute here is short for mutate, and I think we understand that. And I'm kind of breezing through this, but if you're following along at home, you can pause the video and just read through the post with me and then kind of catch up as we go. So you can just keep this open like a little Omarchy window, right? Really easy to use. And so what we're saying here is we have this mutable commands, and it's of type commands. And the important piece here is that if you haven't used a typed language before or only dabbled with it, these types are really good because the compiler can help check us for stuff. So if you're not using a highly capable language, what happens is you still have to check all these things, but you check them at runtime. And so rather than having the compiler check them at this stage, and that's once per build, for example, in the runtime world, well, you might check things infinite times, and you're going to have all these if statements everywhere, and you're going to have these unhandled exceptions pop up and all sorts of things. And that's really where Rust shines, is it removes a lot of the need for that and makes it so that the compiler actually help us make correct code. And so people online will often say that when Rust compiles, you can be fairly assured it's going to work. And that's not always true in other languages. And I think we all know what I'm talking about. So we have a little bit of an introduction to what a type is here. And so a type just tells Rust what it does and what its capabilities are. And then we actually extend those also. So rather than like building each type from scratch, Rust ships with a bunch of tools that allow us to quickly iterate and build out those types, because a lot of types need the same sort of functions. And we're going to see down here in a second about a macro. But if we take this example type here, vec2 is two numbers in a vector, and then we're going to have vec3, which is that. And it talks a little bit about Rust and why it's so efficient. And so if you look at the JavaScript versus the Rust version here, well, every time we do something in the dynamic language, there's all of this wasted space here, which ends up being fairly huge. And so you can imagine if you had a lot of things in your game, you start to pay that price very quickly. And with Rust, it's going to do things very efficiently. And so there is a little bit of overhead, right? You can't just store like raw floats with nothing else. You still need some way to contain it, but it's still very minimal in nature. And this is important too, as he notes, it's not just about the memory usage. What your CPU does is it loads things into cache and it processes them. And so the more overhead you have, the less likely you are to have cache hits. And there's a CPU and it has an L1, L2, and L3 cache. And then there's the RAM access and there's the disk access. And so what you always want to do is if you can minimize that amount of data, you can process them most efficiently. And that's one of the places where Rust is really strong in is they have this concept of having like a zero overhead abstraction where you can do a lot of data structures without a lot of overhead and without a lot of copying of data. And so in some languages, like when you make a new number, it's a new object and it's not just a reference to it. So it doesn't just point to it, for example. It makes a whole new one every time. And then they have these garbage collectors, and these garbage collectors have to try and figure out, is it in use or not? And Rust doesn't operate that way. And so that's one of the huge benefits of it. And you see like there's stories of Discord going from Go to Rust for critical services. And so you can imagine with a game, performance is critical. And the more effort you put into this performance, the more systems it will run on and the more predictably it will run. So rather than having these big jumps in FPS, and if you've ever like looked at the Steam reviews for games, 80% of them are saying the game was fast and now it's slow or things like that. And so that's one of the areas where Rust can actually be a huge value add. For Bevy, the first thing we want to set up is a 2D camera, and that's to see the canvas that we're going to be basically putting sprites on. And then we have a sprite bundle, and that has a texture, color, visibility, all that. And you can see this kind of component diagram here. So we have these attributes, and then we have a sprite bundle and a spawn bundle, and that is an entity.spawn. And if you don't know these things, I don't either. That's why we're reading this together. But B, you should realize that we're learning and it's going to be iterative. And so you're not meant to know the whole story. And one of the things you can do is as you go through this, as we practice it, it will start to show itself to us, and then we will learn it. And by the time you do this 2 or 3 times, you will know it. And so that's the process for anything that has nothing to do with computers, by the way. That's just like the way of life. So what we have here is the first real code. So the other pieces were all pseudocode, and this is the real code. And so what you're going to want to do is go here and say cargo new, and then we'll just say Bevy game YouTube. There we go. And we've created the package. And so we'll say Bevy game YouTube. There we go. And so we are here, and there's actually already a Git repo. And so it says untracked files. We have a git ignore file here, and we have a cargo toml and an src. So quick note on Omarchy, if this is the first time you fired up NeoVim, you're going to see this screen and it's going to be downloading a bunch of stuff. Go ahead and hit the X key. And what you want to do is go down to language Rust and hit the X key again. And then that will install the Rust plugins. And so I've already done that on my system, but if you don't have that enabled yet, it's going to be very handy. And so with NeoVim set up for Rust, go ahead and hit space, and you're going to see all the files. So we have a cargo.lock, a cargo toml, and an src main. And we're going to go back in the post up to the top, and it says there's the cargo commands, and then it says here are the dependencies. And so we have Bevy, and we have 0.17.2. So let's go ahead and go to this pane, and then we're just going to go ahead and paste these in. And so for Vim, it's just hitting the P key, and then we'll just delete this duplicate key. There we go. And you can also see it's telling us that there's also a 0.17.3 here. So it's been updated even since the post, but we'll just stick with the post. And so we'll go back down to where we were at now and back to the real code section. And what we're going to do is hit space again and type main. And you can type like partial MAI or whatever and hit enter, and it will go to it. And you can see here the Rust analyzer is actually running through our code, and it's figuring out where everything is and pulling all the data in. And so that way we're going to have this great autocomplete functionality, and it's going to detect all these errors and stuff as we go through. And so we'll let that run for 1 second while it pulls all down. And while we're doing that, to show you too, if you ever see me pop open a terminal real quick, there's 2 ways to do it. One is I can do the super enter, and that opens a new Omarchy terminal. But I can also open a terminal just in NeoVim, and that's control/. And so I do this all the time. You can see here, so now I'm there, and I'll hit control/ again, and it goes away. And so whenever I need to do like a command, boom, 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 I just toggle between it, and then I don't have to spawn it again. So it's just like instantaneous, right? And so all of our Rust analyzer stuff is complete now. And so what we can do is we can say we want to use the Bevy prelude, and we'll say star. So we'll include everything there. And it should give me a warning. There we go. Okay. So it says unused import, Bevy prelude. And that's because we haven't used anything from it. And that is just Rust being smart about things. And that's kind of why we signed up for this in the first place. And we're going to go ahead and create an application. And what you'll see here is as we type this, actually, let me go ahead and type this app, and we'll say new. You actually get the inline documentation here. So it says creates a new app with default structure to enable the core engine feature. So this is from Bevy. And so we'll say make a new one, and that's fine. And then we're going to add a plugin, and we'll say the default plugins. And this, again, all of these have descriptions, and I'm going to show you 2. So now that we've added this here, if you hit the GD, you can actually go to the source code of it. So what we see here is there's this plugin group, and it has a structure of default plugins with all of these different plugins here. And you don't have to know the ins and out of it, but you should know that if you use GD, you can always see the source code. So you can always like dig deeper. And so we're going to hit Control O, and that will just go back to the original. So you can go to Control I and Control O, back and forth, back and forth. Again, you'll use that like all the time to go in and out of things. And so we'll say we need the default plugins, and then we're also going to add systems. And in this case, we need the startup, and we also need the setup. And setup will not autocomplete because we have not defined that yet. And then we'll say we want to run. And you can see here that the formatting is not totally working yet, but it will in a second when I save all this. So let's say fn setup. And here we're going to say that mutable list of commands we talked about. And it's of type commands. And whenever you make an error here, Rust will definitely show that to you. And that's really handy. And so you know that you went wrong if you see something in your editor outside of the other one. And this will update when I write out the file. So let me do this real quick. So we'll say camera spawn, camera 2D, and then we'll save the file. And so as we save the file, what we'll see here is now the formatting is all fixed, everything's good, and all the errors went away. So if you have errors here, or if this doesn't look like this on your screen, stop here and make sure you didn't make a little bug. So like things like capitalization matters, and the symbols here matter, right? So like at the end of the line, I have the semicolons, that matters. And then what we can do here though, is we can pop open this terminal again and do a cargo run. And this is one of the fun things. So I've been showing a lot of videos with a task monitor here, and we don't have a lot of things to do with it. Like we're like, why would you buy a computer with all these cores if you don't do anything? Well, we can use the power of those cores for Rust. And so we can actually compile all these dependencies and analyze and make sure that our code is correct and everything, and use the compute power available to us wisely. Because again, it's much better to do this up front while we're developing software than to ship it to user and have every single user run these checks every single loop. Like you can imagine how wasteful that is in the grand scheme of life. So we're going to let this run for a second, and you can see we're going at 5.2 gigahertz and about 60 watts. I feel like I've seen this actually go to 130 watts while I was doing this before, but right now it's pretty chill. Oh, it went to 106. So it's still going through. There it goes. And I'm going to exit out of that. And then we have our first game window. So this is exciting because although it doesn't do anything, we have also barely done anything, right? So we now have a game window and a Rust application, and we only typed a few lines of code. And if you wanted to do this, like you were like, hey, right now you're following a tutorial, how would I do this without a tutorial? This is just like straight up out of the Bevy docs, and you could have done this and put this together yourself in seconds. And so don't be intimidated by it. And certainly these function declarations and these types and these commands, well, we just started together, right? Like you're going to know them. You're going to know them soon. So don't even stress for that. So yeah, we have a game here. Everything looks great. And then you can also use NeoVim here and do a space GG, I think it is. Yeah, there we go. And so space GG, we have this welcome screen or whatever, cool. And we can go through here and we can work through Git all through NeoVim too. And so I want to say, I hit Command F here. Command F makes it full screen. So like if you're on a marquee, you have so many options with Hyperland. You can go back and forth between the workspaces, but you don't have to. You can do it like split screen like me, and you really only need one monitor. I have another couple set up here for this live streaming thing because I like to look at the video over here and make sure like, is it recording? Am I speaking? All that stuff, right? But I can do almost everything on one monitor. And then when I'm out and about, right now I'm using the X1 Carbon with Omarchy, and I can switch between my workspaces. Works awesome. But anyways, so we're here, and what we want to do is put these files in. And so if you see here, we have the C key for commit, and we didn't stage anything. And so space is staged. So we'll say, yeah, add the main to RS, add that, add that, add that. And once we have that, we'll just say initial commit here. And you really don't have to add a description or anything, especially because this is just like us playing along with the tutorial. If this was a real bug fix or something, we might have something tangible to say there. And so there we go. So now we are committed, and you can also pull up this terminal again and type git status, and it says it's clean. Git log, and you'll see, oh, there's our commit. Cool. And so we are ready to continue. And so I'm going to do a Windows key F here. There we go. And now I'm back to the display that we were looking at before. And so this describes some of the things we just did. So we have app, we have commands, we have the prelude, which includes the common types that are needed to work with Bevy. And so it's just a convenience. You could import those all explicitly, and you could use NeoVim to do that actually too. And so we'll see if we need to do that later maybe. And so the app.new creates the game application. And then this default plugins here loads rendering, input, audio, and other systems. And again, we can actually see that, right? Just GD. Okay, boom. Yep. There's some time and tasks and accessibilities and assets and scenes and rendering and images. And these are all very nice abstractions because if you were going to do this from scratch and make your own game engine, those are exactly the kind of things that you would define. And so they're already done for us, which makes this really easy. And then we're going to add some systems, which registers our startup function. and the run, which hands over that main game loop. And again, it's all about like render a frame, render a frame, render a frame. That's how any game that you play works, basically. Um, so the startup function runs once before the first frame, and the reason we want to do that is because we can set up our scene, and so that makes sense. And then after the startup, that means our scene is defined, and then we operate within the scene. And so we say it pulls the input, runs your system, updates the world, and renders a frame. And so that makes sense. And there they go, and they run it just like we ran it. And we have a window. Everything's great. So the next thing we want to do is set up a player. And so we want to go ahead and do that. And so one of the reasons I picked this tutorial was because it's so great at explaining everything. And so I'm just kind of running through it like speed run as fast as possible on YouTube with a mix of Linux in here. But it's really worth internalizing some of this. And so he talks about an entity as a unique ID, and that components can have data attached to them. And so we'd have things like the movement speed and the health and special abilities and things like that. So you can think of like comic book characters or RPG characters, right? Where you have these magic spells and everything and capabilities, and you can roll your character. Well, that's all part of the entity we're going to have. And so structs are one of the ways to do that. And so a struct is a core building block of Rust, and it helps group data together. And you may be familiar with that from other languages also, because it's not unique to Rust. And so what we're going to do here is we're going to say this interesting syntax, which I'll get to in 1 second, which is called derive. There we go. And we'll say component. And from here, what we'll do is we'll say struct player. And so if we do this and save it, we'll say that it's never actually used. So it's dead code. Again, that's great because we want to commit things that are actually used, and that's an issue why we just have this sitting around. But the most important thing here is this hash and then derive component. And that's part of the time saving of Rust I was talking about, is that it has these macros, and these macros add functionality onto our struct. And so rather than like, if you've ever seen some old school tutorials, especially with like Java and stuff, you're defining like all of these functions for getters and setters and equality and all that. Well, in Rust, we're able to avoid some of that by just using the repeated stuff automatically through these derived macros. And so this makes our player a component, and Bevy has done all the hard work to implement that. And this is the same deal, right? We highlight that and go to GD. Okay, I can actually see the source code. So here's what it's doing. And now I can't claim to understand all of it, but if you wanted to see what it's doing, that's what it's doing. In the tutorial here, we talk about tags. And so the tag marks an entity for later lookup. Because player is attached to only our hero, systems can ask Bevy, give me the entity with the player tag, and work with just that one. And so this is a way of finding our player and looking it up and just having it exist, basically. He talks a little bit about the macros here and how it generates the code for us, which we kind of already covered. And that's a really nice convenience and an efficiency feature. So whenever those things get updated, our code gets updated, and we can upgrade Bevy, and we can then inherit those benefits. We don't have to cut and paste them everywhere here. And the next thing we cover is what a component is. A component is something which is attached to an entity. And so we're going to have things like the velocity and the health and where it's at in the scene. And what we do is we can query against that. And so we say, where is the player at, and what capabilities does it have, and what's in the inventory and things like that. And Bevy will help us figure all that out. And so the next thing we're going to do is we're going to put something on the screen that represents our player, and we're going to use the @ sign. So I might have said ampersand earlier, not sure, but either way, it's the @ sign. And what we're going to do is we're going to put it in the scene by rendering it as just text. And then later on in the tutorial, we'll make it a picture. And this is basically one of the best ways to develop because it's iterative. So it's like, do the smallest thing possible to make the thing work, and then you can refine it later on. And that's almost how all software development works. And so what we'll do here is right under this commands.spawn with the camera, we'll say commands.spawn again. And be careful with your parentheses here. You can go wrong and get an odd error message. I've done that before, but we're going to say new and then the @ symbol. And then we'll put a comma, and make sure you put the commas in. So some languages you can skip the commas or whatever, but this will go better if you just do exactly as we're typing here. And so we have text 2D that, and then we're going to use a text font. And you can see here we have the autocomplete decorations, and so we'll do that. That's good. And then inside of that, we're going to say font size, make it font 12, which is pretty normal. Font, and we're going to say just use the default one. And then we're going to use this dot dot operator, which we'll cover in 1 second to complete that. And then we'll put another comma there. And we'll say the text color is just going to be color white. And sometimes you can be pretty sloppy with how you type here because the autocomplete will just do it for you. And so we can say that, and from translation, and then we'll say vec30. And basically what this just says is we want to have this, we'll do that in the middle of the screen. So that's what that means is we're going to place this text with the @ sign that's of size 12, that's color white, in the middle of the screen. And then we're going to go ahead and pass our player entity. There we go. And we'll put another comma there. And then at the end of this, we're going to place a semicolon. And if we do that, everything should just work. There we go. And up here, we did add an unused import. And so you can just do DT comma and then delete that. And then we just fix that like that. There we go. And so now all the errors are gone again, and we have something. And after everything we do, just do a cargo run. And you can also make cargo automatically run after everything you do. But here we go. So now we have an ampersand in the middle of the screen. And so you can imagine that our next step is going to be like, could we make it move around? So super cool. We have that there. And I'm going to Control C out of that. Oops, there we go. And now we're going to talk a little bit about what we just did. And so the commands.spawn takes a tuple and treats it as a bundle of components. And this single call adds text we want to show, its font setting, color, position, and the player tag that identifies the entity. And if you go here, by the way, you just go to GD, you can see it just moves it right up the top of the file. So that's the entity, is the one that we've defined in this file. There's no magic there. It's only what we've programmed together. And you can see here, here's an entity. This is player entity 43. And then here's how it kind of looks conceptually speaking. And so there's some default states to it, and that all makes sense. And so as we move down here, we're talking about the camera 2D that's required to see our entity. And so I'm wondering if I remove this, let's see what happens real quick. Okay, there we go. So I remove that, and it looks like it's still going to compile. And so now if we do cargo run, we're going to recompile real quick. And you can see I cannot see my player on screen. And so that's why we have to have a camera, as the camera makes it so we can see it on screen. And so I'm going to go ahead and Control C out of that and do this. And we'll just add the camera right back in and be back where we started from. And from here, we can do a space GG again. And we can just add this in here, and we can commit and say player on screen. There you go. And that will make sure that you can always go backwards if you needed to. And so this talks a little bit about the entity system. And so it says players are just numbers. And, there's some really fun comics in here. And again, I recommend you go through all this also. So just go along with me or whatever, pause the video as you're going through too. It's a great, it's both entertaining and educational. And so now we want to do player movement. And so we have keyboard input here, we have time, and we have position. And these are all really important because you can't do one without the other, really. And so as part of that game loop, when we hit a key, our player is going to move some amount of distance in some amount of time. And so this is kind of what sets that up. And so we have a big move function here, and we're going to make a new function. So let's just do that. So we make a function called move player. And this one is actually going to take multiple parameters here. And so we're going to have the input, and that's a resource, and it's a button input. And again, you can just complete these. So like you see that there, like I got all these. Key code, cool, got that. Boom, boom. And just make sure that your less thans and greater thans are balanced, or you're going to have a bad time there. And the compiler will tell you about that. We're going to have time, which is a resource of time. And after we type this, we'll kind of read over the post, which explains some of this. And then we're also going to have a mutable player transform. And these are parameters our function is taking. And it's going to be a single instance, and it's going to take a transform. And this is sort of how I've seen people program, by the way, with this, is that I'm using a YouTube video right now, which means I'm like talking to you or reading this together and everything. But in your head, or even literally out loud, if you kind of read things out loud, they can make sense. So there's this whole practice online. You might hear people say things like rubber ducking, and it's where you can like say something out loud and it starts to make sense to you. And that's kind of what we're doing here. And so we have the player transform there, and then this is just the parameters, right? And so at the end of this, we should have the closing. Yep, there it is right there. And so what we'll do is we'll actually make the body of the function now, because you could have this all in one line if you really wanted to, by the way. And so either way, just imagine that this is a function signature, and now we have the body, and you probably know that, so we won't dwell on that. And then we're going to say declare a variable here, which is mutable, and it's going to be direction. And we're going to have that be a vec2 0. There we go. And then we're going to basically have the same code that's slightly different. And so we're going to start with if the input pressed is the key code, and we'll say arrow left. And then we will say the direction.x is minus equal to 1.0. And so you can imagine that in a 2D world, we have the grid. And as you move up and down, that's y. And as you move left and right, that's x. And so as we go left, we're going to minus the x. And as we go right, and this might look reversed for you on YouTube, I don't know. As we go right, it's going to go this way. So that looks good. And then you can either cut and paste these or not. When I did this before, it didn't save. I feel like a lot of time, if you're a fast typer, it probably doesn't. But you could try that. Just they're all like slightly different. And then we got to make sure to get the math right here. The way you'll know if you don't get the math right, this is actually kind of interesting. If you don't get the math right, your player won't move correctly. But also, this is something that's a logic piece, which means that the compiler isn't really going to catch it, right? So Rust will catch a whole bunch of bugs, but it won't catch the logic bugs. That's really an important distinction, because logic bugs are something that we as programmers really have to look out for. But we can allow Rust to take the other stuff off of our shoulders so that we can focus on those logic bugs. And so then we'll say if we have up or down here. So I'm just using DW, by the way, to delete words. So arrow left, do like that. And these ones, we know they exist because they're here. But if you didn't, you could go to key code here. And what you'll see is key code is a pub enum key code. So you could actually use any of these key codes, right? So if you're like, hey, I'm already bored with this video or whatever you're doing, and I want to add this super cool feature, you're already like halfway there, because look, here are all these key codes, right? So if you didn't just want to go left, right, or if you want to use the numpad or something, you could use any of these, right? So you could make caps lock go left or right if you really wanted to. You have all that right here for you. And so we're going to stick with the tutorial though, because it's really good. And arrow up, and you can imagine here, instead of using X, we're going to say Y, and we're going to say that if the arrow's up, we're going to go plus 1 up, and we're going to change this to Y and say -1. Okay, and so that all looks pretty good at the moment. And so now right below these, we're going to say if direction is not equal to the vec2 0 right here, we're going to say let the speed equal 300.0. And that's just saying, like, if there hasn't been any movement, skip over this, right? But if there has been movement, declare a speed. And then we're going to say the delta is direction.normalize. And again, this should all autocomplete here. And we're going to say that times the speed times the time.delta. There we go. And that's delta sex. And so we'll do delta sex like that. That looks good. And then we'll delete that and put a semicolon at the end of that line. And from there, we can go ahead and apply it. So we'll say the player transform and translation. And so what we're doing here is we're taking that little @ sign and we're moving it left or right, up or down based on the input of the keys. And that's what these formulas are. And so we say plus equals delta x and player transform translation dot y plus equals delta dot y. And so if we do that real quick, that looks good. And it's saying here move player isn't called yet, because we'll call that in a second. But let's talk for a little bit about what is in this code. And so the res, or the resources, are pieces of game-wide information that are not tied to a specific entity. So the resource of time, it's not just the player's time, it's our whole world's time. It's the game's master clock. And this single mute transform with. So we're getting into some Rust types, and that's kind of why I wanted to make this video and go through this, is because we can do something fun. We can show how easy it is to make games and to get involved. But Rust applies to like many domains also. You could use these same things to do like a fluid simulation or some scientific work or even a cool dashboard or just anything you wanted. And so these skills translate into other things too, and they can be big building blocks. But making fun games can be a great motivator just to learn the process. And then all of a sudden you see a new problem and you're like, wait a second, I have this whole bag of tools. I can solve that too. And so really cool. And so we have this single mutable transform with the player. And so it says, ask Bevy for exactly one entity that has a transform component and also carries the player tag. The mutable transform part means we intend to modify that transform or player position. And that makes sense because that's exactly what we want to do, right? We're using the keys to modify that player's position. And then the single part itself is that if more than one player existed, it would complain about it, which is perfect because we're only going to have our single player game. And so that helps us make sure that things are correct and working well, and we didn't accidentally do something foolish here. We talked a little bit about the vec20, and so again, let's go here, do GD, and you can see here that's 0.0, and we can see here that the splat here just says take a V and return this structure here, which is really this. And this you would find in nearly any language in almost the same syntax, right? So there's can be variances and stuff, but at the end of the day, it's a map with X and V and Y and V. And so you've probably seen that all over the place. And so we'll escape out of that real quick and go back. So either way, it's a vector, and conceptually that vector is just X0, Y0, just like that. So we can't put it there in Rust, whatever, not valid syntax the way I just did it, but that's what it is. And so you can see here, yeah, he has that here too. And that is important. These are floats, right? So there would be 0.0, technically speaking. And yeah, then we have this key code patterns, and I showed you a little bit about that. So if you want to see all the different key codes and everything, and that's defined as a Rust enum, and he says we'll cover that later, so we won't go too deep into that. And then we're just going to check, is it pressed down or not? And if it is, we're going to go ahead and move through that. And we're ignoring the 0 direction. And this part is super important. So when you're making games, you might not have thought of this before. And certainly it's one of those things that like once you see it, it's everywhere, right? So what we're going to do is we're going to normalize it. And it's converting it to vector length 1. And that's because if you were to hold down multiple keys at once and then this loop runs, you'd actually move faster diagonally than you would left and right because there's more than one force operating on it. And so this comes with the tools, and we can actually go here to GD. We can see here that we're in the vector and we're normalizing, and that's the actual code for it. But you don't have to program that. You don't have to know it, whatever. But in any framework or anything you work in, you're going to have to know that that can happen. And sometimes you might even want it to happen, right? Because like as games, there's no rules. We write the rules together right here. You can change any of these together, no big deal. And so we want to normalize that. And then the speed says how many pixels per second to move. And the time.delta returns the frame time, the number of seconds since the previous frame. And that's really important too. So what you don't want is you don't want to hit all these things, and on your computer, you're moving super fast, and on my computer, I'm moving super slow, or vice versa. That's exactly why we need to track the time in between frames. So whether you're on a GeForce 5090 or an integrated Intel card or whatever, you're tracking the time, not like a bajillion frames per second. And so as a new programmer, you can imagine that being a huge issue, right? Like if you're just going to say, yeah, I'm going to move this every frame. Well, that doesn't make sense in most cases. Again, it could make sense in some cases because it is our game. We own it now, right? You can do whatever you want with it, but that's probably what you want by default. And so now what we need to do is take our move player function, and we need to add that on our systems here. So go back up here, and we're going to say that after the other add systems, we're going to say add systems, and then here we're going to say update, and we can just autocomplete that. That's fine. And then we'll say move player right there. And it does take parameters, but we're not going to pass any parameters here. So we're just going to say this and do that. There we go. And so what you see here is that we have this dot dot dot. And so it means the line hasn't ended yet, right? This is all one big line that we're just separating out for readability's sake. And so we have add systems, and then we're going to add systems again. And then this first function here, setup, is called on startup, but this one is called on update. And so rather than being ran once, it's going to be ran every time. We talk a little bit about that here. Why is move player added as update? What's update? And it says move player runs every frame. So we plug it into the update schedule. Update is Bevy's built-in stage that fires once per game loop after startup is done. And so you can see there's actually a picture. And so we'll go ahead and try this out ourselves. Whoops, just do this, cargo run again. And that should compile. And after you've compiled this once, it actually does compile pretty quickly. But you can see here, I'll make this full screen. We have Linux gaming, my friends. The year of Linux gaming is here. We have the best. Now, this little @ sign doesn't have much purpose or direction other than when I'm hitting at my keyboard. But you can see here, it's actually, I'm not sure, I think it's showing on YouTube this way. It's actually pretty smooth too. Like the movement feels fluid, and you could do a bajillion things with this just right off the bat, right? Like if we just stop the tutorial here and we're like, you could think of a lot of fun things to do. Maybe this is a good time to say, if you're a high agency person and you want to experiment and play with things, etc., you could start adding more entities just like this, right? So you could start doing that immediately, and you could do them in a for loop, and you could make a whole bunch of entities. So let's not skip ahead or anything, but that's super fun. And so we're going to do super F to get out of that, and then we'll do Control C over here, and do this and say Control C, boom. And so, yeah, that's the same thing that they have. So they're running on Mac, we're running on Linux, but who cares? It runs on Mac or Linux, no problem. And then this kind of talks about, okay, the system is just a Rust function you hand to Bevy with a sticky note that says run me during startup or run me during every update. And that's very simple and very powerful. And again, we didn't have to think of that or design it. It just came with it. And let's go ahead and hit space GG, and we'll go ahead and commit that. And we'll say we have movement. The fun part about committing this much is A, your GitHub is going to look awesome. You're going to have a bunch of green squares. Congratulations, you did it. And then B, you can roll back whatever and see the progress you made. And that might be useful as the project grows. So right now it's not useful, but as you start to customize it and go down directions, you can make branches and make features that way. So the next thing we're going to do is add sprite graphics, which is exciting. And so there's this universal LPC sprite sheet generator to give the characters some personality. And so you can go and see this link here. And so you can see here, this is actually like a really neat application. So you can make a sprite sheet of a character and all these different things. And you can really customize a lot of things. So we'll just say body, and there's all these like presets here too. So like, you might be super muscular. I get it. A lot of us super muscular or whatever. There's all sorts of things. We can have wings. There we go. So we have like super muscular butterfly man and all that. So have fun with that, and then come back to the video when you're done. Maybe you'll just make sprites. That's also a path. So we want to make our sprite sheet and then put in the SRC assets folder. So I'm going to be boring, and I'm just going to download these sprite sheets here actually, because that is easy and free and already done. So you can do the same thing, by the way. You can just follow the link in the blog post here and do that. And so we have our sprite sheets, and what I'm going to do is I'm just going to open up a new thing real quick, and we are in my GitHub directory still. And so mkdir-p src assets. And then what we can do is we can move home, downloads, and then star.png to src assets. And then if we do an ls and src assets, we'll see there's our files. Looks good. And from there, what we're going to do is it says we need to refactor first. And so that probably sounds like a good idea. So let's see what's going on. We're going to update our main RS with the following, and also create another file called player.rs. And so mod player pulls in the player.rs module and keeps our main file slim. And so that's a really good practice, which is some of the people watching this, you're going to be like experts who have programmed everything. Some of the people watching these videos have never ran Linux or Rust or don't even intend to. And so I'm trying to just, span this balance. And so if you're about to make a comment like, everybody knows that. No, everybody doesn't know that. And not everybody's been in their basement for 50 years tuning this craft, right? So let's go ahead and here and type mod player. There we go. And now that doesn't exist because we didn't make our player to RS yet. And so that makes sense. And you see here, actually, that these errors are really helpful, and probably in a bigger screen, it's more helpful. So it's going to say unresolved module, can't find module file, player RS, or player mod.rs. And so there's two ways to define that. And let's see what he wants us to do. So he says, make that, and then just make the player to RS. So let's go ahead and do that. So we're going to just Shift V to highlight the whole line, and then J to go down, and we're going to hit D here. And then instead, I'm going to do :E, player to RS. And by the way, if you don't want to know any of the things I just typed, don't use Vim if you don't want to. I find it faster and easier, and I'm used to it. I have a little bit of muscle memory there and everything. You could use Rust Rover. You could use VS Code. You could use whatever you want. So a lot of people like Vim because it works with other languages. It's open source. It's actively developed, and it's super fast and lightweight. And sometimes there's even less cognitive overhead with it. So you can always get in these like videos where people are like, oh, I tweaked my NeoVim config for 2 years and now it's perfect, right? You could do that fine. But Lazy Vim has everything in it. And if you haven't seen it before, just real quick, you can go to Lazy Vim. It comes stock with Omarky anyways, but you can do all that here, and it just works really well out of the box, right? Cool. And so what we're going to do is, now that we have the player.rs, is let's go ahead and take this Bevy prelude. We'll do Shift V and then Y to copy that. And then I'll use the square bracket left B or square bracket right B to kind of move between these buffers real quick. So if you see me going like left and right, that's what I'm doing. You can also hit them for help like I'm doing here. But anyways, we'll paste this up top. There we go. And so we have this player here. We'll save this again. And so let's go ahead and make these main changes real quick. And so we see here we have app new, and then we have a insert resource here. So we'll do insert resource, and then we'll say we want a clear color white, which is an enum. And then we have the add plugins, and we have the default plugins. And then right after that, though, we're going to say set and call that again and say asset plugin. And then we're going to say file path. And then this is going to match the path where we put our sprite sheets, the PNG files we downloaded. So we'll say src assets like that. And then we'll say .into, put a comma there. And then this is also going to have the default like that. And then we're going to close the bracket, close the comma, and then we'll say comma here and that. And then we can still add our startup there, but not the update. This will probably go in our other one. So let's go ahead and do that. There we go. And so you see here, we're refactoring this. One of the ways I might suggest doing it too is like, you could just copy this whole file into player.rs and then delete the parts we don't need. That's another way to do it too. I don't mind typing a few times. And so we're going to change this to setup camera. And so when we put setup camera there, it says it doesn't exist, which makes sense to me. And so we're going to go ahead and make that. And we'll say setup camera here. And that's going to be the same signature. We're saying take the commands like that. And then we're saying commands.spawn camera 2D. And what we're doing here is we're splitting things out, right? So here's our original setup command, and we spawn the camera there. Well, now we're going to do that somewhere else. And so let's go ahead and save this real quick. And you can see that error went away. That looks good. And when we talk about what we're doing here, we have this insert resource, clear color white, and it drops a global setting into the app so that every frame starts with a white background. And then if you remember the past, it was like black or gray or something. And then the asset plugin part here, it explains it's the way to load textures, audios, and other assets. So you can imagine us not only putting the sprite sheets in there, but we could have like music in there. And so we could play music while the sprite goes around. And really, we have a lot of options available to us. Now we're getting to player module, and I have a feeling that I deleted some things we might need, but we'll see. So we'll have this dedicated player to RS module, and it's everything related to the adventurer, and it helps keep our code organized. And again, this is like exactly how to develop any software. It's not just games, it's just any software. And so we started with one big main file, and then we're like, oh, this is starting to get unwieldy. Let's make another one here. And so let's go ahead and go back to our player to RS. and we have our component with the player there. Let's also take that Bevy prelude since we need that for the actual functions we'll be calling again. So we'll do that. And then we have some constants here, and that just makes it easy to manage things. So I like that approach too. So we'll say the tile size is a unsigned 32-bit, and we'll make that 64. And so that's 64 by 64. And then we'll say the walk frames is a unsigned, and it's a 9. So 9 columns per walking row. And then the movement speed is 140. So we're going to slow it down from the previous 300. And we'll say 140.0 pixels per second. And then we'll say the animation DT is a floating point 32 bits. And that's 0.1 seconds per frame. There we go. So we'll save that. And that all makes sense. And then now we're getting into some more Rustisms where we're going to define the player directions. And so what we can do here is we can say that we want to derive again. And we want to derive the component, the debug, the clone, copy, the partial equality, and the equality, and do that. And then we'll say we want to define our own enum. And so we saw this earlier with the key presses, how that was an enum. And so now we have our own here. And so we'll say up, left, down, and right. There we go. And I'm using the trailing comma there. We can save that. And again, you can see when I save it, it briefly says cargo clippy down there. So it's just constantly checking the correctness and all that, right? And so an enum lists a handful of allowed values. And so that means maybe our character cannot face ways that are not defined in here. And that's a great way to manage things. So in Go, you might see things like people doing it with iota or something. And some languages have no enum support. Rust has amazing enum support. And so it's the way to do it. And it's very typical and pragmatic in Rust. And it's one of the reasons people really like the language. And so our player only ever faces 4 directions. So the facing enum captures those in one place. That makes sense. And why wouldn't we use a struct here? A struct would need like facing up true, facing left false, etc. And you'd have to keep them all in sync. And that's annoying. Whereas enums are very simple to manage. And it talks a little bit about when we decide between them. And I think that's good to cover too. So a struct is when we need to store several fields like X, Y, player health, etc. An enum is when we're choosing between an option. And so, yeah, an enum could be like weapons. You could have sword, bow, wand, etc. Or when something's active. So that is really good. And then this is exciting because this is sort of like reading through the Rust book, right? And I think that's probably what the author was doing too, is trying to make learning Rust even more fun and entertaining. So this debug macro here, it makes it so that it will let us print this out easily and we can debug it. In other languages, you might see things like toString. And so if you wanted to print something out and format it, you could do that. Or in our case, we just use this debug macro and it's going to look good on our console already. And then we can always customize that further, but it gives us a good starting point. Clone and copy make it trivial to duplicate the value, and partial equality and equality allow us to see if something's identical or not. So again, we get a lot of, you can imagine like we just added a whole page of code, but in one line. Saves a lot of time, and it's very efficient, both for the developer and for the computer this way. The next question here says, why can't I copy through simple assignment? Why should I add these macros? And so basically what we're saying is that in most languages, what you're gonna find is whenever you're doing these operations, it's making a whole brand new one, and it's doing that for everything, and it's not opt-in, right? So like, that's why some languages are 10x or 50x or 100x slower than others, is because these decisions matter. And so we're opting into them for this particular piece. We're saying, sure, it's fine to clone this and to copy it because it ends up being very small. And so it's not a big deal, but we know about it. And so whenever you see this, you can be like, oh, that's what it's doing. And then maybe under the hood, you want to change that, right? But like when we talk about under the hood, like we are at under the hood. So you can change it here if you wanted to. You could choose not to support that, especially for like critical code or something in which maybe you didn't want to make a duplicate each time. That's exactly how you would do it. He covers that a little more here too. And he says, what do you mean that Rust moves values instead of copying? When you assign most values in Rust, the old variable stops owning it, or in other words, dies. Adding copy keeps both variables valid. And so the concept they're introducing here is what's called ownership. It's really mostly a fancy name for declaring something and then freeing it later. And you'll see this in every language. Like Every language either explicitly does it or it's garbage collected. And so Rust has a way where it says, okay, well, I have this variable and I set it to a value, but then I'm setting it to a new value. So I don't need to store that old value forever. And that's what Rust does by default. And so ownership is a way to say, oh, well, it turns out I still need that old value or not. And so if we add this copy piece, the old value also can stay there while the new value stays there. And it says, why does the old variable stop owning and die when assigned? Rust enforces that each value has a single owner so memory can be freed safely. We'll unpack the ownership rules and borrowing in later chapters. And if this is going over your head, it says, yeah, don't worry about it. You're going to learn this over time. And that's why we're doing this, right? Is like, because if it's the first time you're seeing this, you're like, what's going on? But by the fifth time or whatever, you'll be like, I'm a Rust master and I know all this. And so definitely don't worry about that too much. It's just a detail and we'll learn it together. And again, you might learn it in other things. This might not even be the last Rust project you do. And so we have the animated system components. When we have a sprite sheet with multiple frames, like our 9-frame walking animation, we need a way to control how fast those frames play. Without timing control, our character would either be frozen on one frame or cycling through frames so fast it would look like a blur. Think of it like a flip book. And that's exactly what a sprite sheet is, right? So we have a whole bunch of pictures here of our sprites. And then what we want to do is we kind of want to go through them, right? So do, like that. And that's, you would imagine that's where a game loop is doing conceptually. And so Bevy has all of this support baked in, already programmed for us. We don't have to worry about it. But we have a flip book, and that is called the animation timer, which says, like, here's how fast to flip it, because you could flip it slow, you could flip it fast, etc. And so we want to make it look pretty natural. And so we say that we want to put this in the player to RS with the animation timer. So let's go ahead and do that. So we'll go ahead and say the derive again, which again is just throwing code that they wrote for us. And so we don't have to do any of that work. And we have deref and deref mute, which are two new concepts we'll cover in 1 second. And we'll say the animation timer, and we'll say timer, just like that. And then we'll also just go ahead and get this other one done. We'll say derive the component, and we're going to say the animation state. Animation state. This is a really good time to have the IDE check all this stuff, because if you make a really subtle bug in some languages, you'll never find it. This one will actually check most things. So like if you drop the C in facing or something, it's going to figure it out. Some things can't figure it out. And so I really think that that's a huge thing for developer productivity, just because sometimes searching for this stuff can take forever. And so having this find some of it means that I'm not spending time searching for what went wrong. And so here's the what's deref mute macros doing. Deref lets our wrapper pretend to be the inner timer when we read from it, and deref mute does the same for the writes. That means we can just call the timer.tick time delta. And by the way, if you're not familiar with deltas, like delta is the difference between two places. And so in our case, like the difference in time. So if we started at 0 minutes and we let it execute for a minute, that delta is 1 minute. And so in our case, it will usually be a number of milliseconds, because these frames are going to be rendering pretty fast. But delta is just any difference between two things. Another way of putting this is with the references. So you can think of it like when I say these words, they're not just programming words, they're like literal in many ways. And so a reference means that like I don't have the value 3, but I know where to refer to get to 3. And so by doing deref, we're just saying, rather than trying to like find that address and then get to the number 3, we're going to get to just the value we want. And so it's a convenience thing. You could do it without that probably, but it wouldn't be very fun or efficient. So we're renaming the timer to animation timer. We're wrapping the timer, not renaming it. So we have a struct timer, and then we have timer here. And you can think of the animation timer as a little box that holds a timer plus a label that says this one belongs to the player animation. When we spawn a player, we create a fresh timer and tuck it into that box so each player could have its own timer if we needed multiple heroes. So it's an instance of animation time. Yes, animation timer is a tuple struct that contains a timer. We build one when we spawn the players so that each entity can carry its own timer data. This pattern shows up whenever you want to attach extra meaning to an existing type without writing a brand new API. Animation state remembers which way the player points, whether they are moving, whether they just started or stopped. Systems read this to choose the animation rows and reset frames when movement changes. And so you can see here, here's our animation state and here's our timer. And so that way we can have these different entities with different timers. The next thing we want to do is spawn the player. And so we're going to have the sprite sheet through the asset server. And then as it says here, we're going to create the texture atlas layout so that Bevy knows the grid. And we're going to pick the starting frame for the hero facing down. We're then going to spawn an entity with the sprite, transform it at the origin, our marker components, and the timer that will drive the animation. And so right down here, we can start and we can say function spawn player. And this is going to look very similar to the function in main. And we're going to say take the commands, that's fine. And then the asset server. And we're going to have a resource asset server. And this is in caps here, in camel case. And then we're going to say mute atlas layouts. And we're going to say the resource, which is mutable, is the assets and the texture atlas layout, like that. And that should be the end of that line. And then we need a block there. And then now we can say, yeah, let the texture, and this is going to be the first time we're actually loading that PNG file. So we're going to say asset server.load, mal sprite sheet PNG. If you were to run this in some other IDs, you might even have the file name completed. So I think like Rust Rover does that, for example. And so whatever you named your download or however you customized it, as long as it's under SRC assets, which is where we pointed that to. So if we go back here, you can see at the top here, there's our path, right? So whatever you put in there, just remember the name. And you can also probably find that just hitting space, right? So you see here, oh, here are my two sprite sheets and that looks good. And so we'll go back to players RS. And so we have our texture there. And then now we're going to take the layout and we're going to say atlas layouts. And we're going to say add texture atlas layout, and that auto completes. And we're going to say from, and let's move this over real quick, from grid. So we're going to say from grid, like that. And then from here, we're going to say uvec to splat and tile size. So we're going to use the constants we defined up above. And then that way we can tweak these or whatever without changing the code. So like if you didn't like these or you wanted to change them, well, now I can just edit all those. And maybe even we can move those to like a config file later if you wanted to like dynamically do it or something, right? So that's nice. And that's kind of clean and extensible later if we need to. And you could also add that to testing, for example. So you could have tests refer to these or even change them and see if they still pass the test later on. So I like that design a lot. And so we're going to say walk frames as U32, so an unsigned 32-bit. And then we're going to say 12, none, none here. There we go, and put a semicolon in. And that looks like valid rest so far. And then we're going to say let facing, and we're going to start with facing in the down direction, just like the text above said. And we're going to say let the start index, and this is going to be the index in our sprite sheet. So our sprite sheet has, again, all of these positions here, and we just need to index into them, right? So you can imagine like this is 0, 1, 2, 3, 4, 5. That's exactly what we're doing here. So we have all these pictures, and we want to load one based on where we're at there. And so we have Atlas index 4, facing 0, do that. And facing here is going to be face down. So we know that that's exactly where it's defined, face down. Cool. And then we're going to say commands.spawn and make sure to get those parentheses right again. And we're going to say sprite from Atlas image and say texture Atlas. And we're going to say the layout and the index is the start index. There we go. And put a comma there at the end, comma. Yep, there we go. And then we're going to say transform from translation. And we're say vec3, 0 again. And that makes sense. We have the player entity. We have the animation state. And we're going to say, yep, facing, moving is false, was moving. Let's move this over here, is also false. There we go. And the animation timer is timer from seconds. And we're going to take the other constant here. And so it should autocomplete in yours. And we're going to say the timer mode is repeating. So we'll say this repeating. There we go. Put a comma at the end. And we need to put a semicolon here to terminate the statement and end that. And so we'll just save that real quick. And so you can see Cargo Clippy just gave us a check mark, which means that we probably didn't make typos. We don't know for sure. And you can see here, if I go back to the main function, so that that spawn looks pretty familiar here, other than we're not actually going to render the ampersand anymore, which is exciting. That's really all we ever wanted, right? And so let's go through the explanation here of what we just did. And so since I got the code over here, we'll just move down this one. So the animation state, facing, moving, false, was moving. This sets the starting direction and flags that the character is idle right now and was idle in the last frame. And so if we go here, we're in the player to RS, you can see that these are not Bevy things. These are you and I things and the author's things. So we made a struct and we made moving and was moving and facing. So these aren't things that are like built in. These are things you and I coded together. And that's just important to note, like, where does it come from? If we do that go to definition, it's just right here in player to RS. We control that whole thing. And then it talks about the animation timer from seconds, animation DT, timer mode repeating. It creates a repeating stopwatch that fires at every anim DT seconds to advance the sprite sheet. And so right here, you can see we have this anim DT and it's a float 32 of 0.1. And so that's the interval. And so that's just going to keep repeating that again. And that's going to make it so we look like our character's moving if it was moving. So again, it looks like the character's moving if it was moving. So you see the variable name there. Very intuitive if you say it out loud, at least. When you call the asset server.load and the path to the sprite.png, it doesn't immediately load the file to memory. Instead, it returns a handle that you can use later. This is called lazy loading. And so if you were to load like 96 gigabytes of assets, well, maybe only 1 gigabyte is used. And so that will help with the memory usage, especially in a large project, because in a large project, you're going to have many resources, but only a few will be on screen at any given point in time. You don't render the whole world all the time with every asset. The whole world is conceptual and logical in a data structure. It's not all on screen, right? And so like, you can imagine Minecraft. Most of you played Minecraft. Minecraft doesn't render the world as pixels every single frame. It only renders what you can see. And you've probably seen that in the settings, right? You've probably seen something like view distance, for example. And so it cuts off at a certain point for a reason, because it would be computationally not feasible is what the experts say. So we have the lazy loading asset server. And then it says, yeah, multiple entities can share the same sprite without loading it multiple times. Assets are only loaded when actually needed. Bevy can optimize and batch load. That's awesome. And if the asset fails to load, it won't crash the entire game. So that's a huge thing. And again, we didn't have to write that from scratch. These authors just shared that with us. And that's why open source is amazing, because all of these things you'd have to think about at some point with any game engine. And just having that built out means we can focus more on the game. We can focus more on what we want to do. We don't have to focus on doing all this. And so let's move on to the movement system. So now that we have the player spawned with all the necessary components, we need to update our existing movement system to track the direction the player is facing. This is crucial for the animation system to know which row of the sprite sheet to use. Each direction, up, down, left, right, corresponds to a different row in our sprite atlas. And so you can imagine here the sprite atlas. If you see the sprite, by the way, you see sometimes it's facing this way, sometimes it's facing this way, etc. And you see the rows very clearly here. So an atlas helps us figure out where in the sprite sheet should I be? And then that's where our constants also can help us, right? So we say, okay, here's the tile sizes. And then we have the actual atlas layout right here. And it says from grid. And we say right here, we have 12. And so you can see down here, if I keep moving, there's all these different pieces here. And you can also have other things move independently, right? So like, here's just the head. So this has been sort of a tried and true thing since like the 90s. And so there's a lot of prior art here, and you don't really have to do any trial and error. Like, people know how to do this really well, and libraries know how to do this really well. And so this updated system will detect the movement direction and will update the animation state accordingly. So our animation system can pick up the correct sprite row for the walking animation in each direction. And so we have a move player again, and this is going to be very similar to what we did earlier. Let me just go ahead and rip this out of main while we're here. So if you're back in main, you can just go here and do Shift V, and you can highlight this whole move player, then hit D. and we'll just take that and we'll put it down at the bottom here. So after spawn player, we'll make move player. And so here for move player, we have the same input resource key code, the input or the time resource time, and we have the mutable player. And instead of this though, we're going to change that parameter here. So instead of just a player transform, we're going to take a player. So delete that. And then I'm just going to delete the rest of this line and we'll just fill this out real quick. We're going to make a query. And this query is a mutable transform and a mutable animation state. There we go. Completes like that. And we have a syntax error there. And that's because I cut off the lines. Let's do this. Okay. And animation state, and we'll say with the player, and then we'll end our statement like that. Okay, good. So that looks better. And then let's move this one back over. And we're seeing some new Rust concepts here also. So this first line is actually interesting. So it says let OK and mute transform, mute anim, and we'll say equal to player, single mute like that. And let's just see how far this goes over. Okay, or else, and then block. And so the block itself only contains return. And let's just go ahead and talk about this for 1 second. There we go. So we'll do that. So if you notice my vocal intonation when I was typing this in, it's because this is like a super core concept of Rust. But most languages have also either tried to copy it, maybe poorly, or also retrofitted it. And once you start working with it, it's hard to work with other things. And so this is what's called the result. And the result type has 2 values. So it's an enum and it has 2 values. And it has either OK or error. And so what you want to do is like for most things, almost anything you work with, you're going to return a value. And that value could have a good result or an error. And so it's OK or error. And that means that you can start using these features in Rust, like this match thing here. And you can actually say, oh, is it OK or is it an error? And you can check all the conditions for it. And so basically, in most languages, like you're probably used to returning an error. And it depends on which language you're used to. So sometimes you might return the value and then the error. Some languages might not support multiple return values, and you might wrap them up in a hash map or something, and or an array or a tuple or things like that. But the Rust system is super elegant. And so I'm not going to explain the whole concept right here, but just remember that OK is going to be interesting and it's going to be very useful. And then once you learn it, you're probably going to want to get it in other languages too. And so we'll come back to this. So just keep that in mind though. So let's go back up to where we were. And so we're back at the movement system and we've got to line 1 at least. The mute direction, vec 0, that looks good. That's saying that's the same as it was. The arrow left, arrow right, etc. That's all the same as it was. If the direction is not equal to vector 0, then we're going to remove this speed piece here. And we're going to say let the delta is the normalize, and instead of speed, we're going to use that constant now. So again, we can just tweak all of this through the top of the file. And then we're probably going to have time delta sex again. Yep, we do. Great. These lines don't meaningfully change either, other than we're going to, instead of saying player transform, we're just going to say transform. And so we're going to say transform here, and do that. And you can see here, by the way, where did this transform come from? It came from right here. So it says let OK, the mute transform, mute anim, player single mute, like that. And so that's where it comes from. And then from here, we're also going to say that since we know that the direction is not 0, we are moving. And so that's kind of the way we're going to detect that. And so we say animation moving equals true here. There we go. And then if the direction.x.absolute value is greater than the direction.y.absolute value, and that's ABS is just short for that if you see that, then anim.facing is equal to if direction.x is greater than 0.0, we're going to make this facing right. And I'll explain this in 1 second and make sure there's no other things. Yeah, okay, yeah. Otherwise, we'll say it's facing left. And this is using that enum we just made earlier. And so these are our values. They're not Bevy's values. You could name them whatever you want. I don't know. I don't know what other words you have for left or right. You could leave them if you're still here in the video in the comments below. I'd be curious, but I also should be careful what I ask for because you never know what you get in YouTube comments. And so we'll say facing here. If direction.y is greater than 0.0, we're going to be facing up, and then rather than scroll over, I think we know how to do this now, right? We're going to say, otherwise we're facing down. There we go, and we'll put a semicolon at the end. Cool. And then here, also with the movement, if it is actually 0, before we were just bailing out because there's nothing to do, but now we're going to add an else here, and we're going to say, oh, movement has stopped. And so just to kind of cover that, what we just did. Oh, that's cool. You see how it reformatted everything? Made look way better, way more readable. All we're saying here is that if you're moving this way, face that way. If you're moving this way, face that way. Moving this way, face that way. So that makes sense. Like whatever dominant direction you're going in, we're going to make the sprite face that way. So let's talk about the rest of it. It says the query asks Bevy for a single entity tagged player, giving us mutable access to its transform and animation state. We build a direction vector from the press keys, normalize it so the diagonal input isn't more than just left or right input, and we move the player by speed times frame time. The facing logic compares the horizontal versus vertical strength to decide which way the sprite should look. We record whether the player is moving now, so later systems can detect the motion, detect when the motion starts or stops. And so here you can see, here is the actual query. And we say we want to get the transform and the animation state. And then right here is where we destructure those basically into the transform and animation. So now for the animation implementation, we have all the pieces in place. Our player can move in different directions and we're tracking which way they're facing. Then the final piece is the animation system that actually updates the sprite frames to create the walking animation. This system takes the direction information from our movement system and uses the animation timer to cycle through the sprite frames at the right speed. It handles the complex logic of switching between the different animation rows when the player changes direction and ensures smooth transitions between walking and idle states. And so arrow keys go to detect and update position, that's the facing and movement status, and it switches the row and advances the frames. And you can see here that this timer plays into that so that if you're moving, it's going to keep moving. And then it splits the rows and the frames and the player moves. Okay, and so we have this new function here, which is animate player. And let's say animate player. And so it doesn't exist yet. So we'll go down to the bottom here and we'll say function animate player. There we go. And it's going to take the time, which is a resource time. And then we're going to have another query here. And the query is query. And we're going to say that it's a ampersand mute. So reference state and ampersand mute animation timer, I believe. Let's see if that's right. Yeah, animation timer. And then we'll have a reference to a, oops, not $, but ampersand mute sprite. And that's with player. And close that out. Okay, cool. Sorry, this is getting a little long for that line there. And then it says expected a block, which just means we need the curly braces here. Cool. So we have that done. And then we can say, this is looking very similar to the other function, by the way. We're going to say mute anim, mute timer, mute, so you can say mutable too, mute sprite. And we're going to say query.single mute. And it's just going to be this or else. And then we return and bail out, I think. Let's see here. Yep, that's right. And then we'll just add a semicolon here. We're also going to say let atlas equal match. And so I think this is the first time we've seen that so far. And this is a big part of Rust. And so we're going to say sprite texture atlas as mute. And we're going to do this. And then we have some or none here. And so if you remember earlier, I was talking about the enum for the OK and the error. Well, there's another one called option because we want to make sure that a value has been set or not. And that's what this is that it has been set and there's something in it, and we call it some, or it hasn't been set and we call it none. And you'll see this like riddled throughout all programming ever. where people go like, what is the state of not being set? And sometimes people have like a -1 or something, or sometimes it'll be a null byte or all sorts of different things. Well, this solves it very cleanly in a way that the compiler can check. And so this is going to be a huge value add once you learn this, because it makes a ton of sense. And those other implementations can just be fraught with so many bugs. And that's probably the source of like 99% of bugs in the world. So you can see here that we're saying, hey, take this value and then assign it to Atlas. And if there is a value set, just make it that value. Otherwise, just bail out. And so that way, in other languages, you might see this as an if statement, right? Like if the string is equal to quote quote nothing inside or something, it's unset or whatever, right? But that's not like super reliable in so many ways. And we'll probably have to talk about that in other videos or something. Like, why does that not make sense? But this makes sense. And once you get that muscle memory down, you'll reach for it all the time. It's going to be great. Let's go ahead and do this now. So we're going to say the target row is equal to row 0 based. And we'll say anim facing. There we go. And let mute the current column is equal to atlas.index modulus walk frames. And if you're not familiar with modulus, it's like the remainder basically, right? So like 9 mod 9 is equal to 0. 9, we could probably actually do this real quickly. And how about this? Fire up a Python interpreter here, and Python should have something similar. So if we say 9 mod 9, 0, and 9 mod 1 is equal to 0, and 9 mod 2 is equal to 1, 9 mod 3 is equal to 0, 9 mod 4 is equal to 1. And so what you're seeing here is like, oh, wait, what's 9 divided by 9? 1. What's 9 divided by 1? 9. What's 9 divided by 3? 3. So you can see that 4 does not go evenly into 9. And so that's why there's a modulus there of 1, is because 4 goes in twice, but there's 1 left over. And so that's how you can understand modulus. So used all the time in games, by the way. So just keep that in mind. It's a really easy way to confine something to a value. So if you mod that, it will never go bigger than it. That's what people use it for as a shortcut, is like, okay, this will never be bigger than walk frames, because if we have 9 frames and you're trying to reference frame 10, you're going to have a bad day. So that's why you have to do that. So let's go here and say current row is equal to the same thing, Atlas index divided by walk frames. There we go. And then we say if the current row is not equal to the target row, we're going to say atlas.index is equal to row start index anim facing. So that's where we're starting out at. And then we'll say the current column is equal to 0, and the current row is equal to the target row, and timer.reset. So we'll reset our walking animation basically. Oops, how do we have that there? And then we'll say let just started equals to the anim.moving and not anim.wasMoving. And again, these are defined by us. So you can name these whatever you want, or whatever is intuitive to you, or whatever language is intuitive to you for that matter. Like, it could be German or whoever's watching this, you can make it whatever you want. Not anim moving. And these are just conditionals, by the way. These are short circuit conditionals. So what we're doing here is we're just saying, we want to figure out, did the animation just start? And so if the animation was moving and if the animation wasn't moving, then it did just start. And for these kind of conditionals, by the way, you can use these for like everything, because if you're going through a job interview or things like that, they might have you whiteboard or leak code or something. And so just talking through these conditionals will help you like not get wrapped up in things in those interviews. So this could be a very profitable skill just in your whole life. So again, let just started is equal to the animation moving and animation was not moving. And let just stopped means that the animation wasn't moving and animation was moving. And so that's how we know if it just stopped or not. And so if the animation that moving is equal to if just started, so we just started moving, let the row start is equal to row start index animation that facing. and let the next column is equal to the current column plus 1 modulus walk frames. And the atlas.index is equal to row start plus the next column. There we go, and timer.reset. And we're going to say else if it didn't just start. So if we're already moving, then we want to go ahead and tick that timer. And we're going to tick it by the time delta. And so that's just saying that how much time has passed. And this is maybe important to call out. Time.delta is different than timer here, right? So like these are two different things here. And then we'll say if the timer just finished, there we go. Then let row start equal to row start index nm.facing. There we go. And let the next column is equal to the current column plus 1 modulus walk frames. There we go. And the atlas.index is equal to row start plus next column. And so you can see here there's some fairly duplicated things. And so these look very similar. So we probably could have mostly just pasted them if you wanted to. And we do see here I made a typo, which is not caught yet. I'm wondering if I save it. Let's see what happens. I think that's actually a valid statement, but there's another error up here too. So let's fix this first. So, okay, we found that error. Good. And then, oh, you know what? There we go. Okay, so that did format right. It actually was a mathematical expression. So that was valid. Period there instead of a minus sign. Okay, so we have that, and we do not reset the timer there. And then we go down, 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 and we say else if we just stopped. There we go. And we say timer.reset. Okay. And then down below here, we just say the animation that was moving is equal to animation.moving. And that's a really typical thing you'll find in programming is we want to track the state of the last loop. So by setting was moving here, it means that the next time we enter the loop, we can figure out what was the previous frame state. There we go. And so we have a couple more lines here with some functions to put in. So let's just go ahead and do that real quick. We have the function row start index facing is type facing, which we made, and that's going to return a u size here, an unsigned size, and row 0 based is facing times walk frames. There we go. And we'll say function the atlas index for facing frame in row u size. And I think that returns the same u size actually. Let's see what happens there. And then we'll say the row start index facing plus frame in row. So it's going to, oh, I thought it was going to frame in row. There we go. Frame in row dot min walk frames minus, what do we got here? We got -1. Yeah, that's simple enough. Okay, there we go. And if you also notice here too, very important in Rust, this is going to be the implicit return value. So you might not have seen this before, but sometimes we do return and then a value. Well, what happens if I call this function, right? Does it just do this math and it's like, I did this math and didn't give it to anybody? Nope, it returns it. So that's why we actually had to say return u size here, is because there's this calculation happening and that is the default return value. And so that's why there's no semicolon needed there, is that it will just implicitly do that. It makes it a lot easier, especially for these very small functions. So row 0 based, there we go. Facing is type facing, and we'll return a u size here. Cool. And then we're match facing. And this match thing can be used all over the place, and it saves so much time and effort, and it's so clear and concise. And so we'll say there's facing up is, I think it's frame 8, and left is 9, and facing down is 10, and facing right is equal to 11. There we go. Cool. Okay, so we got all that set up, and so far no errors. I don't know about that. We'll have to see if that's real or not, but I want to believe it. And so now I think we're going to explain some of that stuff we just did, and I probably covered some of it. Yeah, so here's the let OK, the mute anim, mute timer, mute sprite, query single mute, else return. It both checks the results and names of the pieces we need. If the query succeeds, the code binds anim, timer, and sprite so that we can use them later. If it fails, if there's no player or more than one, we hit the else and we exit immediately. Rust uses the result type for this. OK means query returned exactly one result, and error means something about the query didn't match. And again, you can see this in like every language, and everything you ever program will use something like this, right? Like most functions can succeed or fail. And you're going to see all sorts of ways to handle this. And in Go, you would type like if error is not equal to nil, all that. Well, Rust has a really great way of handling that. And you'll see that all over the place. And after we match on the option, which is Rust, maybe there's a value. So that's the sum or none. And these two types make up like a huge portion of Rust. So if you have the error or OK, and if you have the sum or none, it's going to be like all over the place. And these are for things like if you imagined requesting a site, you would request, oh, I want to scrape YouTube/Linux, by the way. Cool. Well, maybe you can't connect to it, right? And so you get the error type and you say, oh, okay, we have to retry again, or I can't scrape YouTube because they stopped me, whatever the case may be, right? And then for the contents, maybe the contents are like some or none, right? So maybe the contents was an empty string because something went awfully wrong. And maybe the contents is the whole transcript of this video. It's some, it's something. And so you can use these all over the place. And so it says some atlas means that the texture atlas exists and we can tweak it. None means it hasn't been loaded yet, so we skip it and for the next frame and try again. It's the same pattern we use when checking a map or a cache. Only use the value when the lookup returns something. And so that's a huge Rust concept, very useful. Animate player pulls the animation state, timer, and sprite handler for the player. It figures out which row of the atlas matches the current facing, snaps to that row when the direction changes, and uses the timer to step through the columns at a steady pace. When movement stops, we reset the timer so that the animation resets on the last frame shown. The helper functions map a facing to the correct row and frame index so that the math stays readable. And so that looks really good. And next we want to create a player plugin. And so we have a player plugin here, which is going to be a pub struct player plugin. And now we're going to get into something new also, which is IMPL, and it's going to be for a trait. And so we'll say plugin for player plugin. There we go. And we're going to say in this, we have a trait, which has a function. And I've heard, by the way, for experienced Rust programmers, traits can be complex to manage because it's a way of defining interfaces which are decoupled from each other. So you really have to be considerate about how this is done. But in this case, this is pragmatic Bevy, and we don't really have to worry about it. But as you get deeper into it, just keep in mind that they can add some complexity also. So we'll add startup, spawn player. And again, this looks like really similar, right? So we've kind of already typed these lines before. And so we'll say systems, update, and move the player. There we go. Animate the player. There we go. And if you use these autocompletes, by the way, the reason I like that and talk about it so much is because having that small typo here, like instead of animate player, animate minus player, that could be legit, you know? So this makes sure that we don't make like really silly typos. So that's why I like that. It happens way more than you would ever think, right? And so it says the player plugin is our player module in plugin form. In Bevy, a plugin is just a struct that knows how to register systems, resources, and assets. By implementing plugin for player plugin, we give Bevy a checklist. Whenever this plugin is added to the app, run the code inside to set up everything the player feature needs. This keeps main.rs from becoming a tangle of player-specific calls. The build method is the checklist. Bevy passes us a mutable app, and we bolt on the system we care about. Spawn player is scheduled in startup, so the player appears as soon as the game launches. Move player and animate player go into the update schedules so that they execute every frame, handling input and animation in lockstep. With everything declared here, dropping the player plugin into app new automatically wires the entire player flow. So this build function is an inbuilt structure, which I have to write. Yes, the plugin trait says any plugin must provide a build, and that takes the reference of the self and the app, which is a mutable app function. We implement that trait, so Rust expects us to supply the body. Bevy calls this method when it loads the plugin, which is why we add all of our systems inside of it. And then we talk a little bit about the traits. And so a trait is a contract describing what method a type must provide. Bevy's plugin trait says, give me a build function so I can register your system. By implementing the trait for the player function, we hook into Bevy's startup process and inject our own setup code. And the key piece here is this, is traits let different types share behavior. Player plugin behaves like any other Bevy plugin, but installs our player-specific systems. And so you can see that this is huge because this allows us to implement things that satisfy conditions, and that all makes sense. And so now we can go back to main. It looks like I can clean that up. And so you can see here, our main is littered with all sorts of problems here, right? And so we will go ahead and say that we want to use crate : player, and then player plugin. There we go. And from here, we'll delete this. There we go. And we have an app new insert resource. That didn't change. Add plugins, default plugins, assets. Yeah, we all know that works fine. Then we have our add systems for setup camera. And then we're going to now add a plugins. And we're going to add our player plugin, which is exciting. So that's the one that we wrote. There we go. And now let's go ahead and delete this whole setup thing here. There we go. At some point, I got a little delete happy in main.rs. If you do this also, just make sure we have the prelude here. And you can also see on the left-hand side of the screen, I have the actual source code for this. So in the blog post, they have this here, and you can find that. But we do want to keep the mod player here. There we go. And make sure that's there. And if you're like me and you are doing this all, we haven't tested this since we added player to RS. And so we do have one small problem. So if I go here and do an ls, my player to RS, I created it in the root directory and not in the src directory. So if we do ls src, we see there's where our main is. And so let's move our player RS next to that. And now if we do nvim and open the main function here, we'll see if that's in the right place. And now Rust Analyzer should be happy with that. So just in case, you can also do a space FE here. And space FE will show you your directory structure there, right? So you can see that. We can close that out too. So we have that. Everything looks good. So with the file moved, open player.rs again, and you'll see that we have 3 errors if you typed like me. So you might have your own set of errors here. But we do want to go ahead and figure these out first. And so we see here, this is interesting. We have lowercase animation state. And so it says we might be missing a type parameter here. And so let's go ahead and figure this out. So what if I do animation state with uppercase? And now we are down to 1 error and 1 warning. And so we see here, this says add system rather than add systems. And so Rust is figuring all this out for us and making sure we're typing the right things there. There we go. So that all looks good. And so now what we can do is we can do a cargo run down here. And we are actually getting some warnings, but let's just see what happens here. Well, look at that. So if I go full screen, we now have our sprite, and he's moving, and he's not moving too fast diagonally. And when we change directions, and so this is like, you probably played games, maybe even like this kind of reminds me of Streets of Rogue or something, right? This is the foundation for any 2D game that you want to make. Well, you now have that, right? So like you can go ahead and place things like trees and walls and things like that. And you can say, if it touches it, we'll stop and all that. But this is the basis for it. And so you can imagine right now too, that you could make the map scroll when you get to a certain place, and you could do things like render a mini map. And so you have all this right at your fingertips here. Just through this kind of short introduction to Rust and this blog post. And so I'm really excited because he's continued this series. And there are other posts coming up too about procedural world generations and things like that. So if this tutorial was helpful for you, please go ahead and like and subscribe, and maybe I'll make more. I know this is a very long form thing, but it's useful in so many ways, not just for game creation. You can go ahead and use these same skills now to make a Rust program that edits a config file for you or something, or does something repetitively, or serves a web page, things like that. So as we're doing this, we're growing our skills that we can use in a whole bunch of different domains, and I'm really excited about that. So until next time, thanks for watching, and I'll talk to you soon.